So let's see how to work with these rules. I already explained how to find the Laplace transform by using rule t power n. Like if it is t power 2, here we need to identify the value of n, which is 2. So this rule will give you 2 factorial over s to the power 3. Now we need to work on the other roots. Okay, so if you see, if it is sine at, rule says that a over s square plus a square. So what you are doing, you are just changing the value of a here. Means you are just taking out the coefficient of t and replacing it over here. Similarly, for rule of cosine at, you are just changing the value over here. You don't have to change any other term. So for example, if you have this question, so what you will do, sine of t, if you compare with this rule, sine at, what is the coefficient of t here? It is 1. So if you replace the value of here at this position and this position, what we will get? 1 divide s square plus 1 square, which is nothing but 1 over s square plus 1, and we are done. Similarly, if it is sine minus 3t, yes, it is possible that a can be take negative number. So if a is minus 3, we will just replace. So it is minus 3 over s square plus minus 3 power 2, which gives you now minus 3, keep it same, s square. Now minus 3 2 times, what it will give you? Minus 3 power 2. We can write minus 3 times minus 3. So minus 2 times become plus, 3 times 3 becomes 9. So you get plus 9, and it is always already plus. So this is what you got. Now similarly, if you have cos 3t, so you have to use this rule, cos 8t, which gives you s over s square plus a square, and you have to change the value of a in the denominator only. So here a is 3. So it gives you s over s square plus 3 square, which gives you s over s square plus 9. So you can see the difference in sine and cosine. Denominator is same. In sine, in the numerator you have a number. For cosine you have a variable s. Now it is possible that the value of a is a fractional number. So here a is this value 2 over 5. If you find it difficult to calculate it with 2 over 5, you can convert it into decimal equivalent and work on it. Okay, so it will become s over s square plus 2 over 5 power 2. So this is s over s square plus 2 square is 4, 5 square is 25. That's it. Done. Next question. Now this is t power 6 plus t power 2 divide t. Here you are going to use this first rule. Okay, now how you will use it? That is the question. Here for t power n you have just once. Means you should have one term. Here you have two different terms. So how you will work on it? Yes, correct. First we will split this term. We know the rule that if we have say a plus b divides c, then we can write it as a divides c plus b divides c. We can do it if we have addition in the numerator. If it is in the denominator, we cannot. Okay. So we are going to use now this rule here. So what it will become? Laplace of t power 6 divide t plus t power 2 divide t. So when you do it, when you simplify it, now again we are going to use the rule that x power a divide x power b. It is x power a minus b, that you already saw how to work on it in my previous videos. So t power 6 over t power 1 gives you t to the power 5 plus t power 2 divide t gives you t power 1. Now apply Laplace transform for both terms separately. In the first term, what is the value of n? Yes, power of t, which is 5. So the rule will be 5 factorial over s power 5 plus 1, which is 6, plus, for here in the second term the value of n is 1, so it is 1 factorial over s to the power 1 plus 1, which is 2. So, and in between the addition sign, so we added that term. Okay, that's why we got plus. So this will be the final answer in this case. Similarly, we have other rules. So these are the rules for hyperbolic function. So in hyperbolic function, we say that it's similar to trigonometric function. Like you have a here, you have to substitute the value of a at the two places for sine hyperbolic. The difference from trigonometric is here it is minus. Similarly for cos hat, it becomes a square minus a square. Okay, and for Dirac delta function, if it is minus a, you are writing it as e power minus es. Okay, the important thing that you need to notice that here there is no t term, sorry. When you find the Laplace transform of any function, it should be a function of s. It should not be a function of t. So let's see. Sine hyperbolic 9t. So here the value of a is correct, 9. So use this rule. So it is 9 over a square minus 9 square, which gives you 9 over a square minus 81, and stop. Next, here sine hyperbolic of minus 9t. So here a is minus 9. Apply it, minus 9 over a square minus of minus 9 square. After simplifying it, don't do mistake like a square it become plus. No, it will not become plus, because when you solve minus 9 power 2, it gives you minus 9 times minus 9. Minus 2 times gives you plus. 9 times 9 give you 81. So it will be, now minus 9 square become plus, so you have left with minus 81. So for hyperbolic, no matter what, the denominator will be always negative. Now if you have for cos hyperbolic 2t, so a is minus 2. Using this rule, replace a in the denominator, what we will get? S divide a square minus 2 square. So which is equal to s over a square minus 2 power 2 gives you plus 4. If you have cos hyperbolic of 3t, here a is 3. So it gives you s over a square minus 3 square. So s over a square minus 9. I hope it's clear. Now, if it is delta t minus 3, now we are going to use this rule. Delta t minus a gives you e power minus as. So e power, now as it is minus 3, so minus 3s. Means we don't change the sign. We take the number 3 and we put the number here, and the sign will be same as well. Similarly, if it is plus 3, so we take the number 3, so e power 3s, the sign is positive, so we make it plus s. I hope it's clear now.